In the previous video, we were introduced to acceleration. Let's go through an example with uniformly accelerated motion. When traveling 40 feet per second, I suddenly apply the brakes and slow to a stop in 8 seconds. We want to fill in the graphs for this motion to help us visualize what is going on. We will also assume a constant deceleration. First, let's look at speed versus time. Initially, at time 0, we are traveling at 40 feet per second. So we can place a dot there. After 8 seconds, we are stopped, so our speed is 0 feet per second, so we can place a dot there as well. Then, since we have a constant deceleration, we need to draw a straight line between these points. Now, let's draw our graph for distance versus time. The distance will be the total distance from our initial point. Before we start drawing, let's think about what we have going on. Initially, we are cruising along at 40 feet per second, which means we are traveling 40 feet every second. As we press the brakes, we slowly start to slow down. In the last few seconds, we are moving, but we aren't traveling as many feet each second. So our distance versus time graph will be a curved line, since the distance we are covering per unit time is continually decreasing. Now, we want to find your deceleration. Remember, deceleration is a negative acceleration. We can use the equation circle to find our formula for acceleration, which is change in speed divided by time. Our change in speed is going to be our final speed minus our initial speed, or 0 feet per second minus 40 feet per second, which equals negative 40 feet per second. We can take that and divide by our time, which is 8 seconds. This gives us negative 5 feet per second squared for our acceleration. We can't forget to include the negative sign since we are slowing down. Now we want to find what your average speed is. Remember, average speed is initial speed plus final speed divided by 2. Our initial speed is 40 feet per second, and our final speed is 0 feet per second since we are stopped. We can then take 40 feet per second and divide that by 2, which gives us an average speed of 20 feet per second, which is what you would find at the midpoint of the speed versus time graph. Last, we want to find the total distance it took you to stop. Remember, with uniformly accelerated motion, distance is equal to your average speed multiplied by your time. In the previous part of this problem, we calculated our average speed, which was 20 feet per second. We can multiply that by our time of 8 seconds, and we end up with a distance traveled of 160 feet. If we look at the distance versus time graph, we see that at 8 seconds, we have traveled 160 feet.